All right.
Are we gonna have that in our class too?
No, just me. All right. This is day 2 of recording. I hope it records, because if not, then I got to do this again. All right.
How would step cousin even work?
I don't know. That's what I'm trying to figure out.
Don't worry about it.
Be very worried
JD's
about
mood
it.
strange today.
I can tell. I can tell. Good morning. Good morning. Good morning. How are you? Good morning.
Eat some cake.
Good morning. Good morning. Good morning. Nice one. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning. Good morning, Krill. Why didn't you show up to D&D yesterday? Why weren't you at D&D yesterday?
I had things I needed to do.
Can I go get my notebook?
Among other things.
It's in my locker. I'm sorry. I
After
forgot.
Damien, he asked first.
I
Go.
forgot it was
Sign
in
out.
there.
Did you sign out? No. Okay, sign out and then go. Sign out and then go.
Now?
Wow, okay.
But
All
I
right.
can go right now.
Wait.
You got the packet.
Yes, I got a packet.
I'll take it.
Why are you late?
Because my locker wouldn't open.
Because your locker would on. Why are you late? Okay.
Kid these videos.
What do you need?
Bro, he wasn't
Shoot.
even there.
If I pay attention and take the notes like I'm supposed to, can I borrow a computer to talk to someone who's trying to? I'm just setting up an interview.
Borrow a computer during lunch
No, right now.
to set up an interview.
Yes,
On what? What platform are you using to talk to him?
I'm just using. We're
Like
emailing
email?
each other. Yeah.
Yes, you can use it. Yeah. When at least one of those two people gets back. Okay. All right, sit down. I'm sorry. Oh, sorry. Sit down, sit down, sit down.
Stop it.
Sit down, sit down, sit down, sit down. All right. You've probably noticed I've got that thing stuck to my neck again.
No.
Yeah, I have to record myself again. So,
Hello, recording.
today's going to be a weird one.
Hello.
Are we doing?
JD says hello.
I also
Nah,
say
you're
hello.
back there.
Hello.
Yeah. Okay, silence.
That camera?
Yes, that camera.
How dare you?
Silence.
Silence and fidelity.
Okay. Today, we are going to talk about chemical reactions. It's going to involve 2 separate demos, one of which means we're going to have to go outside. During that demo, I need a cameraman who can follow me around and make sure that I take the video correctly. I like you, you do it. Actually, I want you to catch the bottle. Lily, I want you to film me.
Wait, I'm doing what now?
You'll see.
I've been conditioned for photography by my older sister.
I have to record racing for racing.
I'm going to ignore that and move on. Okay.
Ignore that.
All right. Yesterday. Oh, grab things to pull out notes, guys, as per usual. Hang on. Is it not following me? Oh, come on.
In there. Just not if you can hear me. Is there anyone? Relax. Get some information first.
You should let me have 7 seconds unattended.
There is no pain in receiving. There's no chance of going
Okay. Yesterday. What did we talk about yesterday?
Science. We talked about
Insulation and chemical bonding.
Chemical bonding. Thank you. I'm so happy. Someone was paying attention. We're talking about chemical bonding. We talked about the 3 types. What are the 3 types? Ionic, metallic, and covalent. Well done. You guys make me proud. Man, I hope that works. All right. There you go.
Oh, I thank you.
Uh-huh. All right. ionic, metallic, and covalent bonds. Now, we're going to talk about breaking those bonds.
Breaking Bad?
Sure. We're going to talk breaking those bonds. That is a process called chemical reactions. That's what we're going to talk about today.
Oh, sir.
So, what is a chemical reaction?
Oh, something chemical.
It's when you put two
chemicals
chemicals that don't
reacting
like each
to
other
each other.
together and then they go boom.
Not always. Sometimes they like each other and they...
Like when you do
It's when you put two chemicals together.
Ooh, how topical. A chemical reaction is when you have two substances that come together and create a new substance that wasn't there in the first place.
Like an explosion.
Sure.
So you're
Like I take oxygen and hydrogen and I make water out of it.
it's chemical breeding.
Sure. Or I take baking soda and acetic acid, combine them together to create sodium acetate. Right? There you go. There are many different kinds or signs that a chemical reaction has occurred. The first of which that we're going to talk about right now is the production of gas. Fantastic example, as Lynn so eloquently put it, is baking soda and vinegar. Does anyone know the chemical equation for baking soda?
I don't think I know.
You know, for a moment there, I was going to be like, Raphael actually knows it and didn't just look off of the sheet in front of him. Chemical equation. This is baking soda. This is vinegar. You do not have to write this down. It's not underlined, is it?
I wasn't going to anyway.
Then why make the comment?
Why is the example?
Okay, fine. This is baking soda. It's got sodium in it. Baking soda has sodium in it. Whatever. This is vinegar, also known as acetic acid. And it reacts to create sodium acetate, water, and carbon dioxide. Now, carbon dioxide. What is the natural state of carbon dioxide at normal temperatures? It is what? It is a gas. Gas builds. Builds to form pressure. That pressure can be used to do crazy cool things. I hope not like actual explosions, but yeah, technically. Yes, baking soda vinegar volcanoes are a fantastic example.
I love those.
Yes, Lynn.
Are we gonna do the things that were set for today?
So what do you mean I'm going to catch the ball?
You'll see.
It's going to hurt.
Make them catch the ball.
All right. Who wants to see it in action?
I do.
Yes.
Oh yeah.
Yes.
You want to see it in action?
Coolly.
Cool. Here's the deal. We're going to go outside to the engineering dock, and we're going to do something with bottle rockets. However, if we're going to do that, I need you guys' word that you're going to play well, be good students, not mess around, etc., etc., etc. Do I have your word? Yes? I want it from everyone. Do I have your word?
Yes, sir.
Good. JD, you're a senior. I will F you in this class. Give you an F. All right, yes.
I'm going to grab my hat really quickly.
Why you need your hat?
Because like outside it's bright.
Oh, that is true. Yes. Go quickly. Grab it out of your locker. Meet us out there. All right. Yes.
What are those?
You know that's fair.
That is probably a chemical reaction. Although it says H2 and O2 in a 2-to-1 volume. I don't know why it's bubbling. I don't know. It was a cool picture. Whatever. All right. Are we ready? Okay. Now comes the fun part. I gotta spin this out. Ooh. All right, Lily. You're gonna hold this. You can see it.
Yeah.
You just gotta point it at me. The base is gonna be spinning a lot because it's trying to track me, but I need it to keep the camera on me. All right, we guys ready? No. All right, if you're ready, line up. Kitty, Kayla, let's go. Let's go, let's go, let's go. All right, we ready? Let's get out of here. Go. Head to the engineering dock. That is correct. What are you guys waiting for?
Are we gonna go?
Yeah! Let's go!
It's worse because it's like a dim and then it goes back to full bright.
I was just behind people that weren't moving.
I know.
That's the worst part.
Waiting for everyone to move. Cool. All right, you guys can go too. Thank you. Johnson, will you send on signal that Sharp's class is going to the engineering dock?
Okay.
Thank you. Yeah, start walking.
Got a trash can, man. It can't find him.
That's not your fault, sir.
Yeah,
That is?
yeah, I took it out of the case.
Look, your phone has been on practice.
Yeah, that's my phone.
Really?
It still functions. I know that's like crazy, but it does still function. Okay. I want everyone on the far side of that concrete line.
I'm guessing I'm going over here.
Yep. Except for Raphael.
Are you gonna shoot something at us?
I'm gonna shoot a rocket at him. Huh? Yeah. Please don't drop my phone. Okay. You want someone else with you? All right. I promise, one at a time.
Hydrated.
Raph, remember you can't half out. I got you.
All right. I am adding 200 milliliters of vinegar, and it's going to be about 10 to 15 milliliters of baking soda. Yes, I know it's a solid, and I'm measuring it with volume. I know that's weird. Just roll it. We're just going to pretend like that works and not worry about the fact that density plays a key factor in it. Moving on. Wee more, right there. Yeah. If you guys want to make this on your own, notice how he took that tissue, found the center of it, shook it out, and turned it into a cone. I'm going to shove that cone down in the top. Oh, come on. You worked like half a second ago.
Isn't that how you make a Molotov?
Can you stop telling the class how to make explosives, dude? I'm trying to have a good, safe class here. Okay. Once I plug it in there, I'm going to fill it with baking soda. I got to use my finger to kind of plunge it down, pack it in there. Huh? Oh yeah.
No hard feelings, but it would.
I think you're gonna want to go that way. All right.
Maybe stand a little closer.
Are you gonna aim it at him?
Yep, that's what this stand is for. Okay.
Target practice.
I want you guys step a little closer, guys. I want you to be able to see this. What I want you guys to look at is when I flip this over, watch the tissue. It's gonna bubble and pop, and there's gonna be a whole lot of gas escaping from it. That's what I want you guys to see.
We're gonna get hit with the cork.
Nope, the cork stays exactly where it's at. All right, you see it? It's creating a lot of gas, right?
Whoa!
No! So close, dude. There you go. I know. There you go.
Do it again.
I'm gonna do it again, but I want to see how high the cork goes.
The tissue gets.
I'm just gonna leave it upside up and just see how far up the cork goes. Yeah?
Let's do
All right.
Huh?
To catch the cork too?
Sure. Why not? Make you catch that.
You saw it moving, sir.
Yeah, I did. That was a good one though. You almost had it. You were closer than the last class. The guys in the last class, which I had half the class. Not close,
The
dude.
wind like started blowing
I know.
this way, and then it just started flying the other way.
Yeah. Yeah, the other class, that thing was all over the place. Got 200 milliliters of baking soda. You can sort of see it creating and reacting with what's left over in there, right? That's creating the gas. Oh, yeah. You know what this is. There you go.
And one time,
If you like seal the cap on there and it blows up, yeah.
and then I'm like waiting.
It's always the weight. The weight is always the hard part where you're like,
Go, no, go.
it's not going. It's not going. Let's see. That'll do. And probably just a little bit.
Go up to like 20.
Nah, because you don't want too much. If you have too much, then you have unreacted product in there, which actually causes problems.
Put some more in there. Just double the ratio.
If I put too much in there, then it doesn't have enough room to explode. Trust me, I've done the math on this. This is the best way to do it.
How close do you think I'll be with the...
With the cord, I have no idea. It shot up in the hallway, because I did in the hallway in first period, and it shot up to the ceiling so hard, it like disappeared and then teleported to the ceiling and then fell down again. So I have no idea how high this thing is going to go. It might end up on the roof. If it does, I got to buy her a new quart. Mr. Ray. All right. Ignore the fact that I'm making a mess. Okay. All right, you guys ready? I'm just gonna drop it in there and just watch the cork fly.
Catch the cork.
You ready? Ye of little faith, Krill. What? Ye of little faith. No, I don't think he did.
Am I gonna shake it?
Nope.
You gotta shake it.
Just patience, guys. Wait for the build, the anticipation, man.
Like, I like shaking.
You know what would be really nice if it did go on and then we tried to like...
Yeah, we're not getting that one back.
It got run over.
Raphael! Raphael!
It just got run over.
Raphael! No, come back here. I'll get it later.
Wait, how are we supposed to use it?
We're not. That was the last. I just wanted to show you that. Oh, yeah.
Drink it.
All right. Come here, guys. Come here. Everyone, come here. Hold it. Touch the bottom of that. Not quite. I wish it was more.
Is it warm?
No, it's actually cold. Because baking soda and vinegar is an endothermic reaction, it actually gets colder. There you go.
Yeah, it's fine.
A little bit.
That's a little cold.
A little bit.
Yeah, it's fine.
That's warm. I don't know what you're talking about.
I don't know what to tell you, dude.
Trying to find it.
Man, you guys are no fun.
We know.
No, this was fun. I enjoyed this.
It's like room temperature.
Okay, fine.
I bet you if you shake it, you can still blow it up.
With my finger.
No, like close the cap and then just go.
I don't have the cap with me.
No, the
There
camera
you go.
side.
All right.
Camera side.
Very cool. You guys ready to go in? Yeah. I want all the guys to run a lap right in this courtyard and then head inside.
I'm not running laps.
Just the guys. Because you guys have too much energy.
I don't have energy. I don't know. Can we drink ball shots now?
No.
I can do it, sir.
No. Okay, yeah, you do it, her. There you go. Thank you. All right.
I told you I could do it, sir. You're actually very surprisingly light.
That's fair. Okay. You guys ready?
No, sir.
There are other classes going. You need to be silent, okay?
Sir.
All right, let's do it. Get back in there. Garrett, will you hold the door? Thank you. After you, JD. Let's move. March.
The camera's gone.
The camera?
How do
Yeah,
we
I
know
know.
you're not being a bad teacher now?
I don't know. Great question. Let's go, Crow. I did. Well done. Thank you.
Thank you.
After you.
You did nothing.
I'll race you to the class.
Krill. Really, dude? Really?
That was me, not him.
Yeah, I know.
Yeah, for sure. Okay, that was.
Will you motion on signal that I'm back? Please. Huh? Thank you. All right. Thank you very much. Ooh, that's one to move. I apologize for the spinning. Just to get it on there. Krill, if you do not stop, I'm going to write you up. Thank you. Where are you going, dude?
Over here.
There. All right. Cool.
It's not even real simple.
I know. I hope you don't do it again, because then I'm going to have to write you up, okay? Like that.
That was an accident.
My guy, what did I just say?
I can't not.
All right. So you guys saw with your own eyeballs a...
That's not me.
Are we ready? Okay. You guys saw gas production with your own eyes. That's how we shot the cork across the road. That's how we shot the bottle across the yard. You all right? Huh? I have no idea. Sorry. Next sign of chemical change is color. Color change is technically the primary sign of a chemical reaction. Ronan, take notes. Signs of this, or examples of this, include rusting. We've talked about this a lot. Rusting. That's iron turning from a shiny metallic color to a rusty, dull brown. Where are your notes, bro?
I don't got no paper.
You got no paper.
No paper.
None whatsoever.
No.
Can you ask someone else for paper? Why are you so kind to him? Oh, good to know. Next one is tarnishing. Do any of you guys have silver rings? Or any form of silver, like spoons or anything? Not copper. They turn black. Yeah,
Don't they turn your skin green?
they can. No,
No, that's
not silver.
not real silver.
No.
Yeah.
Fake silver does, but not real silver. Yeah. Or whatever you call it. I don't know what you'd call that.
Depends on the person too.
Oh. The very first ring that I ever wore was made out of silver. And I wore it down until it snapped from the inside. That means I'm technically part werewolf.
Wow.
Because my body was literally eating silver from the inside.
It would have burnt your fingers.
How does that make you a werewolf?
Silver werewolves.
Well, aren't werewolves immune?
You know, have you ever seen like a dark fantasy? Like ever?
Yeah, werewolves are vulnerable to silver, sir.
Alright.
Yeah,
Alright,
depending
I'll
on
do
the
that.
person, the
Sir, are you the alpha wolf?
you did not. Oh my God. Some people won't turn
No, I am not an
and
alpha.
stuff like that, but others will.
Fair
That's
enough.
what I think is interesting as well. The alpha.
All right.
We hear your alpha wolf cry.
No. That is not something I'm going to share with you.
You have one? Oh my God.
Wouldn't you like to know?
No, I would not.
Uh-huh. All right. So, in this picture, you get an example. This is silver, right?
No.
As the silver, over time, is exposed to the air, it tarnishes and turns black. I used to have a silver ring that I wore a lot. Different one than the one that I snapped, but different one. I wore that one long enough that it started to tarnish. And I had to stop wearing it because it was black. And even though that's the vibe, I feel like all the jewelry is silver, right?
Why didn't you clean it?
Because I don't have the money to take it to a shop.
You don't have to
take it to a shop. My
Sure,
grandma uses toothpaste and a toothbrush to clean her jewelry.
You can also,
Didn't know you could do that.
you can also get,
Now I do. In bacon?
Vinegar.
Oh, okay.
I don't know why you heard bacon.
I don't know why I heard bacon.
Yes, bacon.
Okay, sure. I'll put it in bacon. All right, we're getting distracted. Moving on. Next one is oxidation. We've talked about this a lot. Oxidation, typically the most common example is rusting. However, in this one case, we're going to talk about apples.
How's that proper?
Apples rots, because it's not oxidation, it's corrosion, different thing. Apples, when exposed to air, will rot and turn brown. That turning of brown, that's a color change. That's a sign that a chemical reaction has happened.
Prove it.
Nothing?
he's gonna throw an apple at you.
Thank you, Gabby. You get a fresh apple and a rotten one.
That's why you put lemon water on them. When you put them in a bag. Because they stay fresher for longer.
I'm learning a lot today. You guys are schooling me at this point. Do you guys remember me talking about how oxygen is technically a microscopic explosive?
Out of the air.
Yeah? Yeah. So oxygen, when you breathe it in, it is a key component of the Krebs cycle. A little biology tangent for you. Krebs cycle, that's ATP, that's what your body turns calories into energy so that you can move. That requires oxygen. Really, bro? Okay. That oxygen, as it does the reacting, will burn. It literally explodes inside your body in microscopic atomic explosions, right? So, technically, you're powered by explosions.
We're a car?
Yeah. You're basically a car. Last one I talk about is indicators. I use this a lot in college in my chemistry class. The best one is called phenolphthalein. It is spelled wrong on the PowerPoint. It is spelled like this. Phenolphthalein. 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 Yes?
I can't spell.
I can't help you with that, bro.
Feet felon.
Yes, Raphael. Last 10 minutes of class, yes.
Running at the top right now.
We might get there. So yes, go. Sign out.
Sometimes I accidentally mix.
All right, you guys ready?
Yes.
Shoot.
Should we do that experiment with the...
Phenolphthalein?
Yeah.
I can't know.
Why?
Because I'd need an acid, a base, and phenolphthalein.
Lemon juice.
So phenolphthalein is an indicator. If I have an acidic solution and I add phenolphthalein to it, it's still perfectly clear. But if I add a basic solution to it, it starts to turn pink.
Water?
Meaning it turns from like clear to pink. Like that.
What if it's a solution?
Anything on the pH scale above 7, we're going to talk about that later. You got to add it in very small increments because it is really, really sensitive. If you add just a little bit too much, you screw it up and you got to start over.
Do you not get that turning, you know, whatever?
Phenolphthalein.
Whatever.
Phenolphthalein.
Do you not get it?
No, I can't.
Is it like a legal?
No, it's just a controlled indicator substance. So I'd have to go through my college, which would be a weird request. So I don't know if they'd let me do that. It's called a titration if you want to look it up.
Well, sir, you never know. Everything.
That's fair. Ronan, sit down. All right. Last sign that a chemical reaction has occurred. It's temperature change. Oh, okay, yeah, sorry. I was like, why did you shout sodium? Speaking of sodium, there's two kinds of temperature changes. Who can tell me what they are?
Exothermic and endothermic.
Are you reading the slide? How'd you know that? Well done. All right. There are two kinds of temperature changes. There is up and down. Increase in temperature change is called exothermic. Means heat is exiting. The reaction is releasing energy.
So it's hot.
It's hot.
That's cool.
Yup. How you doing,
Sir,
dude?
Wiley's flirting with me again.
Wait,
Are
again?
you drunk?
It's hot in Topeka. That's a thing for you, book.
Oh, okay.
Sir, can you get Wiley? He's flirting with me again.
No, he's not. He's flirting with his online friends.
No, he's. Oh.
What? All that.
In an exothermic reaction, heat exits the reaction, heat goes up, etc., etc. Fantastic examples are fire, the obvious one, and hand warmers.
Like firebending?
Fire and hand warmers. Take it from a guy who worked in a haunted house for about 5 years.
That's dope.
You become very, very close friends with hand warmers. When it is October in Colorado at 4 in the morning, it gets really cold. So I've got, yeah, that's what the hand warmers are for. So I've got them like in my gloves and down my shirt and down my pants and in my shoes just to stay warm because it was that cold.
Wait, sir, were you a scare actor?
No, I was part of security.
That's.
Meaning all the drunk people that would go through, I'd get to, as they're like stumbling down a corridor, just snatch them into the hallway and then chuck them out the side. Yeah, it was great. Scared the crap out of other people too, because they're like, oh, he got taken. It was awesome.
Yeah.
I love killing.
The other type, if exothermic is heat goes out, what is endothermic?
Endothermic is when it gets cold.
Heat goes in, it gets cold.
What?
Like the
Oh, I hate this so much.
If it's exothermic, heat is exiting. If it is endothermic, heat is entering.
What?
Dude, I can't help you. I like your sticker, dude. No,
Yeah, my grandfather gave me this.
that's a good one. I like it.
Doesn't the energy level of the electrons and the electron shell arrangement have something to do with
Specifically the valence electrons, yes.
that? Yeah.
Fantastic examples would be cold packs. Not the ones that you stick in the freezer and they freeze, but like the chemical ones. So you can get chemical packs that actually are an endothermic reaction, they're cold. It's like the reverse of hand warmers.
It was just 21.
Also, didn't really show it very well. I'm not going to lie, I was kind of disappointed. But the baking soda and vinegar technically is an endothermic reaction as well. Key indicators that a temperature change has occurred. Who can guess?
It's colder.
It gets colder, it gets hotter.
Steam or
Rosa
like
Parks.
what?
Bubbles, did they?
Okay. Temperature change, not state change. However, state change does make sense. There's an instant change in state. If your solid turns into a liquid, you've increased heat. If your solid turns into no. If your liquid turns into a solid, it decreased heat. Here's a visualization, a picture of it. Edwin, what are you doing? Okay. All right. Exothermic. Wiley, eyes on me. Krill, eyes on me. Exothermic reactions. If this is my reaction, heat exits the reaction, meaning heat goes from the reaction to my hand. Therefore, I feel warm. Right?
So then the thing will be cold.
No.
It gets colder.
It feels warm because the heat is going into your hand.
As time goes by, as more heat leaves it, it's going to get colder. So the only reason why you feel the heat in the first place is because it's actively releasing heat.
Yes. Endothermic reactions.
Is when you.
Right, Wiley, here's something to keep in mind. Your hand isn't inside the reaction. It's outside.
What if it is?
And you have problems.
Then you've got problems.
Yeah, let's go
Be
back to school bus
disintegrated.
situation. Let's go into this thing.
Endothermic reactions. Eyes on me, please. Endothermic reactions. If this is a reaction, heat is entering. Endothermic, heat enters. But if heat is entering, that means it is leaving my hand and going into the reaction. If that's happening, what does my hand feel?
Cold.
It feels cold. Does that make sense?
No. Yes.
Are you okay?
You guys both looked at me with the same expression, just like.
It's because we know you understand. Heat enters the reaction, it leaves my hand feels cold. Exothermic, heat leaves the reaction, goes into my hand feels warm. Make sense? Okay. Moving on. We've talked a lot about signs that a chemical reaction has occurred. Now we're going to talk specific types of chemical reaction. Where's your notes? Let me see. Nice.
This is what I've got. So
Perfect. That's good. Keep going.
Except these ones are better.
First type of chemical reaction is oxidation. We've talked some about this already. Oxidation means a reaction with oxygen. This usually happens very slowly over time. Can anyone tell me why? You want a better ruler, dude?
Yeah, you got one?
Yeah, there's a whole pile of them over here.
Oh, perfect. Thank you.
Who can tell me why it happens over time? Krill.
It's because over time the oxygen goes into whatever is oxidizing, and it's like, what a chat here. And then all the molecules start to mingle, and then they're like, whoa, I love mingling, but unfortunately it's super late, so I gotta start going home. And then some of the molecules are like, oh man, I'm really glad oxygen is gone, and then they go somewhere else.
What you're saying is that the reaction itself is slow? No. The reaction itself is instantaneous. It has to do with the atmosphere.
It's not fully oxygen.
Yeah, what you're breathing right now is only 16% oxygen.
Wow.
The vast majority of it is actually nitrogen, which is an inert gas. It doesn't bother us. Fresh nitrogen.
Is that why it hurts to breathe sometimes?
Actually, that's
It's because you're not drinking enough water, and it's burning your throat. Yes.
much
But
oxygen.
when divers come out of the water sometimes, they put them in like nitrogen chambers to get them accumulated.
Yeah, it's called the bends. So,
I got a question.
when a diver who's really, really deep in the water surfaces too quickly, what happens?
They have nitrogen poisoning or something.
They get nitrogen poisoning. They get microscopic bubbles of nitrogen gas that build up in their system. And that's called nitrogen poisoning. We call it the bends. They call it that because it twists you and bends you because it's agonizingly painful.
There just has to be an impression capsule.
It's like
Yeah.
drowning in air.
Ascending 10 meters at a time and waiting. And then ascending, and then waiting, and then ascending, and then waiting, and then ascending, and then waiting. Which means you have to have enough air, oxygen in your tank to make it.
Is there?
Yeah. Yes, if you breathe too much oxygen, you get oxygen poisoning, which is a bit like, I don't know if I told you guys this, it's a bit like if you were running your car on pure nitrous all the time, it'd just melt your car and burn it out. That's what it's like. Okay.
Because it's usually people from the coast going up a mountain real
Yeah.
quick.
How does one breathe too much oxygen?
Have pure oxygen, have it set too high.
Oh, pure oxygen. Okay.
Yeah. Astronauts and divers have to worry about it.
Oh, I'm neither.
Diving is actually a really complicated adventure, like balancing gases and making sure you don't get the bends and timing and making sure you have enough for all of that. It's a lot. Okay. Great example of oxidation is rusting, which we've already kind of talked about a little bit. Example demo. Here's my next demo. In these 3 beakers, I have 3 pieces of iron, each in a different environment. In this beaker, this piece of metal has been exposed to the air for about a week. There's very little rust on it.
Is that like the control?
This is the control, yeah. Very little rust on it. That's because it's been exposed only to air. And it takes air a very, very long time to oxidize pure iron. This next one is pure water. Actually, technically it's tap water, but you know, pure water. There's a lot of rust on that. And that is why. Why do you think that is? Because water's like half made of oxygen, which then reacts with it and causes problems. This third one, however, is strange, and I'm not really sure the answer to this. This is salt water. This is enough salt in this water. I packed it with enough salt to where it couldn't dissolve anymore, and then tried to get it dissolved, and then made that.
How is that?
If you'll notice, there's a little less rust on there than the previous one. Why do you guys think that is?
There's more
Wait, I think I know, sir.
taking up more room, not enough oxygen.
No.
This is just a theory, but is it because the salt water abrased the iron as it dissolved, and so the salt kind of shaved off the parts that would have rusted? It just like how polishing rusted iron removes some of the rust.
Interesting theory. I have no idea. My thought process was that the water was tearing apart the sodium or the salt into its component parts. That's sodium and chlorine, right? That sodium was bonding with the oxygen in the water, yanking it out so that it couldn't do anything. That's my theory. That's a good theory, though. It could be that the sodium is actually attaching to the metal itself and like coating it so that it doesn't rust. Could be why. I don't know. Interesting theories. Anyway, rusting. Again. Okay, fine. Rusting. What does rusting do to things like bridges?
Thanks to Maker.
Good.
It weakens them by a lot.
No point.
If you have a car driving across a bridge that is heavily rusted, there's a significant danger that that car is going to go through the bridge and into the creek.
Even if it's wood.
Yeah, because if the bridge is rusting, that means the wood is definitely rotted by that point. Yeah. Anything rusting like that causes significant safety hazards and high risk. Keep that in mind. Next type of chemical reaction. It's combustion. I wish I had a demo for this, but I cannot light anything on fire inside the school. So.
We can just tight.
Pulls out.
Hmm?
You know, my hands are touched on fire. Sugar.
We need to stop.
Yeah?
Use that.
That's fair. I don't have one. Combustion reactions require three things: fuel, oxygen, and heat or spark to start it. You get those three things together, and you get fire. You guys seen Castaway?
Yes.
That movie is awesome. And the scene where he creates fire is hilarious. For a fire to be started, it requires all three. You must have fuel, oxygen, and heat. What happens if I just have oxygen and heat? I've turned the AC way too up. I just got hot air. What happens if I have heat and fuel? But no oxygen. I've just got toasty fuel. That's it. What if I have fuel and oxygen, but no heat?
Congrats, you have just fuel.
I have very well ventilated fuel. That's it. And what happens if I have, I don't know, what's the last two? Fuel, oxygen. Okay, oxygen, heat, heat, fuel. I've pretty much done them all. Obviously, none of those work. I have to have all three.
Fuel and spark and no oxygen.
Fuel and spark. Okay, yeah. Well, no, if I have fuel and heat, then I just have toasty fuel. There you go. This, obviously, is an exothermic reaction. If you have an endothermic combustion reaction, I'm honestly kind of surprised and shocked that you're able to break physics. It's an exothermic reaction. Welders use it, engines use it, heating systems use it, heck, even gas-powered sticks use it. You guys don't know that reference? Oh, that makes me sad. No, it's from a show called Bravest Warriors. It's a good show. Anyway, they all require fuel. They all require combustion reactions to be powered. right? They require massive amounts of heat and combustion. Nice. Have a fantastic day, ladies and gentlemen. I'll see you tomorrow. Thank you.
Yo, sir.
Yes.
You should watch the Bear Grylls survival.
So you got it.
Is that following you? Or
It's tracking me. If I take this and go.
can I, like, I'm gonna just.
But also, my bottle rocket lab is missing now. It says it's missing even though I turned it in like yesterday.
Which part? There's 3 parts.
I don't know.
Wait, you turned it in yesterday?
I turned it in like 2.
Okay, that means I've graded it and it's in my Excel gradebook, but I
Oh,
can't
but it's not
do
in
anything
my
with it because
public.
it's not in IC.
Okay, thank you,
Yeah.
sir.
See ya. Dude, what did I tell you about washing your hands? Did you try orange soap?
No.
Did you try paint
I
thinner?
forgot to go.
Bro,
I was
your
ready.
hands are still like Smurf blue. Yes.
I have an interview tomorrow at Burger King.
Nice.
Right after school, 2:30.
Well done, dude.
Yeah.
Well done. You have a fantastic day. That was 4th period. Obviously a little more chaotic than I would have liked, but that's how the day goes. Yeah, all right, cool. Thank you very much. Thanks for watching.